Hi everyone, I'm Cuong, and this is CollaVR. Oh, sorry. This work was done with my advisor Feng and collaborators at Adobe Research, Steve DiVerdi and Aaron Hertzmann. Okay, so we have already been introduced in this session about 360-degree video and virtual reality video. So in this talk, I will refer to virtual reality video as motoscopic 360-degree video that is viewed in a VR headset. So compared to viewing this type of video on a desktop computer or on mobile devices, viewing 360-degree video in a VR headset provides a much greater sense of immersion. And I can say that VR video is an emerging art form. So an important question to look at is how do we produce content for this type of new medium? And it turned out that filmmakers are currently adapt conventional filmmaking practices into producing VR video. And if we look at a general pipeline for VR video production, it may contain similar stages in conventional production, like planning, capturing, editing, and reviewing. So in my talk today, I will focus only on a very interesting process called video reviewing. So in conventional video production, video reviewing is very important. People frequently need to collaborate, review, and feedback on edit. For example, an editor may need to explain a video story to his client. In bigger studios, we have teams of editors working together with directors and producers. So video reviewing is really a collaborative process. But when it comes to VR video, collaborate, review, and feedback are much more difficult. To understand why, I need to emphasize that in order to fully experience VR video, a person needs to wear a VR headset to view it. But wearing the headset blocks communication and makes video reviewing really challenging. Collaboration in VR is not new research. There have been solutions that were developed to support planning, storyboarding, or watching video together in VR. But these are not video reviewing tools. Also, there have been research that focus on video reviewing on desktop applications, but these applications are generally not suitable for VR because they were designed for conventional 2D video on a desktop computer. So in order to really understand how people can review video together in VR, we started by interviewing 4 VR professionals to learn more about their workflow. So in this talk, I will briefly go over the high-level design goals that we learned in these interviews and describe an implementation of a prototype system called CollaVR. So based on the interviews, these are the high-level goals that we learned. And these design goals generally aim to resemble the social interactions that we use in our face-to-face conversation. For example, for awareness. We want people to quickly understand how people around them are looking or doing. For view sharing, people who work together in video usually find some way to watch video together or share their screens, so we want to enable this behavior as well. And finally, for note taking. Taking note is not really easy in VR, so we want to provide a convenient ways for people to take note and share and review their experience in VR. So to realize the design goals, we implemented a prototype system called CollaVR that can enable multiple users to review VR video together while fully immersed in VR. And as an overview, here we have 2 users using CollaVR. And in their VR view, you can see that they can see the video in the background. And on the foreground, they have several tools and visualization that allow them to work together. So CollaVR was designed for the co-located collaboration scenarios in most film studios. So we made a few assumptions about the system design, like we assumed that it was connected in a fast local network. To reduce bandwidth, media files are stored locally and only the interaction between users are shared. And CollaVR used these shared interactions to facilitate collaboration between users. And here are the collaboration tools that we developed. For awareness visualization, recall from the design goals that we basically want people to understand how people around them are looking or doing. So first, we provide this viewport visualization. As an example, here we have 2 users, red and purple. And in the purple user view, you can see that there's like a red rectangular viewport. of the red user, and the same thing happened in the in the red user view. So these viewports are very useful in a 360 environment because they can quickly convey both the view direction and the view area of collaborators. So now we play the video to demonstrate it, but please pay attention to the red user and her viewport because it's going to move. So what just happened is that the red user just turned all the way to the left, and so that's why her viewport is no longer visible in the purple user view. And when that happens, we provide this off-screen arrow visualization so that, let's say, if the purple user wants to locate the red user, he can follow this arrow like this. Now, these two users are looking at the same view again, and they can also draw on the video to pinpoint a stitching error that they want to discuss. Our system also supports voice chat, but the interesting thing here is that we spatialize the audio voice chat with the view direction of the speaker. So what this means is that, for example, this user is speaking. So when that happens, the red user over here will hear his voice as if coming from the right. So spatialized voice chat complements viewport visualization very well because it allows users to quickly find their collaborators without having to visually search for them. When we collaborate with somebody in person, we usually pay attention to their reaction and their activity. But these information are lost in VR, so our system provides a minimal interface to visualize these activities. Each user are represented as a color icon with their activity shown below the timeline. For example, if I look at the user 2, I can tell that she's watching the video and commenting, and now she's pausing and also draw something on the video. This activity visualization provide a low channel for me to, and it can be very helpful if I want to just quickly glance at what my collaborators are doing. The next set of tools support view sharing. So when people collaborate over a video, they typically engage in many view sharing activities like look over shoulder, watch together, or for coordinated reviewing. One person controls the video and the rest of the team sit back and discuss it. So to simulate this condition, we provide a set of tools for people to share and synchronize video playback. Picking allows a user to glance at the video feed of other collaborators. With following time, two users can synchronize the video time together so they can watch the video together. For example, here, after clicking on following time, you can see that the video time of the two users are synchronized, so they can watch this video segment together. Another type of synchronization that is unique to VR video is slaving. So compared to following time, slaving allows two users to synchronize not just time, but also view direction. When that happens, one user becomes the master user, and another user is a slave user. In slaving mode, these two users share the exact same view in VR, so it can be very helpful if they want to discuss fine-grained issues in VR. But an inherent problem in slaving is that when the head motion between these two users conflict, it can be very nauseating. So to support effective slaving, we developed a new slaving visualization. In this example, on the right, we have the master user, and on the left, we have somebody trying to turn on slaving mode. And when that happens, you can see that the slave user can have a same view with the master user over here. And the interesting thing here is that instead of rendering the whole master user view on top of the slave user view, which can be very nauseating, our system only renders a smaller copy of the master user view. This is very important because it allows the slave user to have to see her own video in the background, allowing her to have some sense of self-motion, which can be very helpful to reduce motion sickness. Finally, as I mentioned earlier, taking notes in VR is not really easy because people don't generally know how to describe a VR experience. So CollaVR allows users to record a VR experience as a note. A note is basically a multimodal data that captures view direction, speech, video interaction, and drawing. And after recording, these notes are available on the timeline. The audio content is transcribed, and clicking on a note will allow a user to review it. During reviewing, everything that has been recorded will be replayed, allowing users to review their experience in VR. And if you notice, we also use the slave visualization here to reduce potential motion sickness. We conducted a preliminary expert study to see how the collaboration tools in CollaVR can help expert users review video together. And we recruited 5 professional filmmakers from local studios, divided them into 2 groups. We asked each of these groups to watch and critique 2 VR documentaries, and these documentaries were produced by an amateur video editor. We compare CollaVR with a baseline system that is basically CollaVR without any collaboration tools. It only has a timeline control to control video playback. I will now highlight some of the key results in our study, and for more discussion, please refer to our paper. First, let's look at the video reviewing patterns. Here's a visualization of group 1 using CollaVR and using baseline. So recall that in group 1, we have 3 users, T1, 2, and 3. In the video time visualization, the horizontal lines mean the video is pausing, diagonal lines mean the video is playing, and vertical lines mean somebody is seeking or jumping in the timeline. So looking at this, we can see that these 3 people spend most of the time browsing video together when they use CollaVR. But when they use baseline, they try to do that at first, but then later on, they just branch out and do their own thing. The view similarity visualization, so how much time they spend watching video in the same direction in VR. And looking at that, we can see that again, when using CollaVR, they spend more time viewing similar content compared to not really doing that in baseline. And the same result can also be observed in group 2. When using CollaVR, people spend more time browsing video together and watching in a similar view direction compared to not doing that in baseline. The next result focuses on communication patterns. The conversation of participants in each group were coded by 2 researchers, and we focus mostly on the type of verbal references. So when people collaborate over something, they either use implicit or explicit references. And usually having more implicit references means a good sign of collaboration. So our results show that when these experts use CollaVR, they ended up using more implicit references in their discussion. And participants reported that the view sharing tool and the visualization allowed them to ground their conversation. So overall, our study was really preliminary. We only have a few expert users, but the results were promising because we found that expert users were able to use CollaVR to review video together relatively unhindered in VR. But more importantly, they spend more time viewing video together and use more implicit references in the discussion. So these results, I think they suggest that the collaboration tools in CollaVR can potentially support effective collaboration around VR video. And our work is only the first step in exploring the collaborative potential of VR video. There are many other possibilities. For example, one limitation of CollaVR is that it only supports small group collaboration. It could be extended to support bigger group. For example, one good application is in education. Maybe a teacher can take a whole classroom onto a virtual museum tour that has been captured in VR video. Also, CollaVR right now only support co-located synchronous collaboration. It would be really interesting to explore other types of collaboration around VR video, like remote collaboration, asynchronous, or collaboration between different devices. And that concludes my talk. Thank you for listening, and happy to answer your questions.
Favorite questions. So thank you, Cuong. One question I have is just this question about scale that you touched on at the end. Can you talk a little bit about how well these techniques scale as the group grows? I mean, you know, a giant class maybe is kind of one extreme, but what about 4 or 5 or 6 people?
Sure, that's a good question. Thank you. So in terms of scale, most of the feature I presented here would be able to work with when more people join in. But I have to point out that the Viewport, the awareness visualization and the spatialized voice chat, it would not work well with a lot of people. Because like for spatial audio, if we have like 10 people, it would sound really chaotic. And also having a lot of viewport will be very cluttering. So I guess a good idea to potentially explore how we can support more people is maybe to let user decide who among the group they want to work with and let them form smaller groups based on their role in video reviewing. Thank you.
Okay, Junhyuk Lee from KAIST, South Korea. Thank you for the great talk. Just out of curiosity, what kind of editing could the users in your user study could do? Because and what kind of notes were they making? Because I don't know, I don't think there are that many kind of editing techniques available for 360 video editing these days. So what kind of things were they editing and what kind of communications were they having?
Sure,
Just out of
yeah.
curiosity.
So yeah, that's a good question. This is just based on our observation in the user study, and when people like take note or like comment reviewing this video in the study, they focus a lot on a few topics. For example, on video image quality issues. For example, stitching error is like a really common topic. Like people point out whenever they see stitching error, and like they talk about how they plan to fix them later. And they also talk about whether a certain segment in the video is nauseating or not. Because like, different people, I would say, experience VR video quite a little bit differently. So also they talk about the quality of sound. So that's some example I could think of.
Hello, it's Hyung-Jae again from KAIST. Isn't there any need for 360 video to be reviewed from diverse perspective of views? I mean, if there's the need to be this video to be reviewed on diverse direction, and it can be dangerous if the tool nudges to nudges users to watch in the same direction.
Can you repeat it again? I couldn't.
Is there any need for 360 video to be reviewed in diverse viewpoint?
In diverse viewpoint?
Yes.
What's your question? Was it about whether we could review a video in different viewpoints?
Yeah. I mean that 360 videos should be reviewed in diverse viewpoint.
Yeah. I think so what CollaVR offer is like basically a tool for people to review. I mean, it's really up to the team to decide how they want to review it. Like in the user study, I found that like in group 1, the 3 of them like just kind of like look at the same thing all the time. But in group 2, they kind of like coordinated the task. Like one person look over here, the other over there, and then once they find something interesting, they just like jump into the same view. Did that answer your question?
Yes, that was.